Good day to all. We are going to see the blended yarn cost in this lecture. How to do a costing for a blended yarn. We are going to see on polyester cotton blended yarn through Drawframe blending. Before that, we'll see what are the various types of blending that are available. First is blowroom blending. So in blowroom blending, we have cotton and polyester. In the earlier blow rooms, they lay cotton and polyester bales side by side, and the same blow room line was used, in which the polyester is given a harsh treatment and unwanted cleaning is given. But now in the modern blow room blended lines, I'm going to show you the reater line. In the reader, you will have for the cotton line, I am showing the picture of the Uniblend A81 from the website. So you can see the mix blend three different type of materials, polyester, cotton and viscose. The cotton will have previous 2 or 3 machines for cleaning, and the separate lines for viscose and polyester, and you can set the blend ratios, and accordingly you will get a blended yarn. They say that it is put in the Rita website that when you produce using UniBlend, you will have a uniform blended yarn as shown in the figure compared to Drawframe blending is what we claim. So we'll go to the blowroom blending process flowchart, another type of blowroom blending, which is conventionally used in the mills. So you will have a separate cotton line. So the cotton bales would be laid, and you will get a mixing. You will do mixing, blowroom, and carding. Instead of card and sliver, they will directly join it to the blended line, wherein the polyester and this clean cotton is fed to the next blow room. Here in this next blow room, the settings will be very open, not like the cotton line. This will have open settings as no cleaning is required. For uniform blending alone, this is followed, and then the usual carding also the settings will be open as the already the cotton is clean. So this will have open settings, and next you will have the breaker finisher draw frame, then speed frame and ring frame. So, or draw frame 1, draw frame 2, speed frame and ring frame. So let us see the process flowchart for draw frame blending. So this will have a cotton line. I'm showing the process for a carded yarn production. So you will have blow room, carding and a draw frame. And similarly for the polyester line, you will have blow room, carding and drawing. And then both the slivers mixed in the blended line draw frame, and you will have 2 passages of draw frame, speed frame and ring frame. And next for this I'm showing for a combed yarn. So the cotton is combed, and the combed sliver is blended in the draw frame along with the carded sliver of polyester, and you will have the forthcoming processes. You can refer to this paper in IJFTR, wherein a comparison of various polyester cotton blended yarns are done for combed and super carded yarns. The process of flowcharts used in this paper, which I referred, are the first sample 1 and sample 2 are combed yarns, and sample 3 and sample 4 are super carded yarns. So these type of flowcharts are used for producing blended yarns. I showed this to you to give an awareness that there are various process flows that you can follow for producing the yarns. So our concern is costing. So today we are going to see draw frame blending, and for you need to understand on the process flowchart for understanding and doing cost calculations in a better manner. Let us look into the given particulars. So the first is the count of yarn. The count of yarn is 80 NE. Then we have the uh, 2 fibers that are used for blending, cotton in the ratio of 60 and polyester in the ratio of 40. So the blend ratio is given. Next is the cost data. So the cost of cotton per kg is 165 and polyester per kg is 95. Next, the other data for the uh, cotton line. So I said it is Drawframe Blending, which we are going to see. So the cotton line, and it is a combed yarn. So the cotton line will have blowroom, card, pre-comber and comber. The waste percentage and cost per kg of the cotton line are given. Blowroom 5.5, card 4.5, and pre-comber and comber together is 18% of waste. And next, the cost per kg of blowroom waste is rupees 30, of card waste is 35, and the comber waste is 60. Next, let us come into the polyester line. Polyester line, as the polyester does not have waste, you can see the waste percentage in blowroom and card is 0.1%, and polyester is a comparatively cheaper material. So the cost per kg of the waste is given as 12 rupees per kg. Next, we are going to blend the two in Drawframe. So let us look into the various departments. So we have after in Drawframe 1, 2, speed frame and ring frame. Altogether, the soft waste is 2.5% and the hard waste is 0.35%. The hard waste is sold at rupees 35, and this soft waste, is reused. It's a usable waste. So let us look into the, and you can assume that the uh, cost of this usable waste as the cost of the polyester, because it is this is used in the polyester line. As it is a clean material, it is not used in the cotton line. This material is used in the polyester line, and you can assume the cost of polyester as this usable waste cost. Then additional cost details that are given are the conversion cost and the profit percentage. Conversion cost is in rupees per count per kg, and the profit is 6% of selling price. So let us see how to find out the cost for this. So let us take this cotton line first. So let us try to find out the input and output and the waste kgs and the revenue through waste. Similar to that of 100% cotton yarn, the calculations are similar. So these are the various headings which you have to put and the various departments. And then first let us assume that we put a kg of 100 kgs of raw material in the blow room, and the waste percentage is 5.5. So the output will be, yes, 94.5 as it is 100, and the waste in kgs is 5.5. The formula input into percentage will give you the waste in kgs. So input minus waste, you will get the output. And the revenue of this waste, 5.5 kgs of waste, is sold at 30 rupees. This is there in the question already. This is the data that this waste data and waste selling data is used here. And 30 into 5.5, you get 165. This is the revenue generated through the blow room waste. Next, let us come to carding. The output of blow room is your input to carding. So 94.5 is the input to carding, and the waste percentage here is 4.5. So 94.5 into 4.5 by 100, you get this waste kgs as 4.2525. So 94.5 minus 4.2525, that is the waste, will give you the output. Input minus waste is the output. Now let us see the waste selling price. You have to enter this from the this data 35. So 35 into 4.2525, the waste in kgs, you will get the revenue through waste. Then let us come to Comber. In Comber, the input is the output of card. So the input to the Comber is 90.2475, and the waste in total of for pre-comber and comber is 18%. So 18 divided by 100 into 90.2475, you get this 16.24455 as waste in kgs. So input minus waste in kgs, you get the output as 74.00295 as the output of the, so the combed sliver output kgs is 74 point this. So next let us calculate the waste selling price for the pre-comber and comber waste, that is the noil waste. So it is sold at 60 rupees. This is used actually in OE and production. So you can see the higher price of the comber because we purposely remove, it is not a trash material. We purposely remove the short fibers. It contains only good cotton. So let us calculate the revenue. Revenue is waste selling price is into waste in kgs. You get the revenue through waste as 974.673. So we get a total of the various revenue through waste, the total. So this is the revenue through waste for the cotton waste. So we have got two data, the cotton input to Drawframe for blending is 74.00295 kgs, and the revenue through the cotton waste is 1288.5 rupees. So this is the two things we have calculated from the cotton line. Now let us see, try to find the polyester that is to be given as input to the line, because we have assumed 100 kg of input in the blow room line here. Now we have to find, according to the blend ratio, what is the amount of the raw material slivers that has to be given as input in the draw frame. So we already have the percentage of cotton given in the question here is 60%, and the polyester is 40%. So we come here, the percentage of cotton is 60 and the cotton kgs is this much. So we can find the total kgs of material given as input. 60% is 74. So 100% is 74.00295 into 100 divided by 60. So we get the total kgs as 123.34, and so to find the polyester kgs, total kgs minus cotton input, you will get the material that has to be given as input in the draw frame, or the kgs of polyester that has to be given as input in the draw frame. So we have found both. Now we have to find for this sliver. This is actually the sliver that is given as input. So what is the both are here also, it is a sliver. So we have this sliver and this sliver. So we have to now find how much raw polyester has to be put in, and the revenue through waste in the polyester line. This is a backward calculation. For the cotton, it was forward calculation as we assumed 100 kgs of input. Now it is backward calculation. So for this kgs of polyester, what is the so the output of card here is because the card output is given as input to the blending draw frame, as this is a card yarn. So we have this kgs, and we know the formula that we already used in the cotton yarn 100% calculation. The same formula has to be used here. Input is equal to output divided by 1 minus waste percentage divided by 100. So this is used for backward calculation. Forward is simple. Using this formula, and 0.1 waste percentage, we get the input as 49.38468. And input minus output, we get the waste kgs. We can see the smaller amount of waste as it is the polyester line without any trash. And the waste selling price is rupees 12. So the revenue generated through waste is a very low amount of 0.592616. Next, let us come to the blow room. The input to the cart is your output to the blow room. So 49.38 rounded off to 2 decimals. And the waste percentage again here also is 0.1 percentage. So with the same backward calculation, we find the input to be 49.4341, and the waste in kgs is input minus output, so it is 0.4943, and the waste selling price is 12, and the revenue generated through blow room waste is 0.5932. So the total of the polyester waste revenue generation is 1.186. So we already have the cotton input to Drawframe. We have found the polyester input from this, and the revenue generated through cotton waste is 1288.5, and the revenue generated through polyester waste is 1.186. Next, this calculation, we will see the blending. So we have a draw frame input. What is the draw frame input? Is equal to this kgs. This total kgs of cotton and polyester is your input to the draw frame. Since we did backward calculation, we should not put this. So here it is backward calculation. We should put the total kgs here. So this is the total kgs that is given as input to the draw frame. Let us see the blended material calculation here. So the blended flow has draw frame 1, draw frame 2, speed frame and ring frame, and the total soft waste is given in the question as 2.5%, which is already given, and this is the usable waste. And next, from this input and soft waste, we can easily calculate the soft waste in kgs. 2.5% to our 2.5 divided by 100 into 123.34, you get 3.0835, and this is a usable waste. And next is the hard waste. Given in the question is 0.35%, we can see here, and the revenue through hard waste selling is rupees 35 per kg. So let us find the hard waste in kgs. We have the input, so it is easy to find 0.35 into the divided by 100 into 123.34. You get the hard waste in kgs to be 0.4317, and the outputs in kgs of the ring frame is 119.823. This is 123 minus soft waste and hard waste. So the total waste is 3.0835 and 0.4317. The waste subtracting these two waste from 123, you get this ring frame output. So this is your production, blended yarn that is produced. So let us now calculate the revenue through waste for this hard waste. So this soft waste is added to blow room, as I already said. So we take this cost of since this usable waste is used in the polyester line, we assume this polyester cost per kg as the usable waste calculation. It will give a higher value, but still we use that as an assumption for calculations. And next we have the hard waste. So we will use both these things here. So rupees per kg, we use 90. So the cost of soft waste is 90 into 3.0835. This 90 into 3.0835, we get 277.91. So this is the revenue through soft waste. And next is the revenue through the hard waste. Cost of we have the selling price of the hard waste as rupees 35. From the question here, we have this here. So from that into the waste in kgs is 0.4317. So 35 into 0.4317, we get the revenue generated through hard waste, which is 15.11. Revenue generated through soft waste is 277.51. Revenue generated through polyester waste is 1.186, and the revenue generated through cotton waste is this much. So I will highlight that in all in red color. Revenue through cotton waste, revenue through polyester waste, revenue through soft waste. This is usable, but for calculations we use this, and for the hard waste we use this as revenue. Okay, this is an assumption. This yellow color highlighted is an assumption for calculation purposes. So let us now calculate the costs from these data. So we have the cotton, which is 100 kgs of input. In the start we assumed 100 kgs of input here. You can see here in this I am highlighting it in different color and de-highlighting. So we have cotton. This is 100 kgs, and the cost of cotton per kg is 165. So we put that value 165 here. And polyester, we have here, we have polyester is given as blow room input. This value has to be taken. So this one I'm highlighting, 49.43412 is the polyester input. So that we have to take, and the cost of polyester is 95 rupees. So it is given in the question, this is the 95 rupees. I'm highlighting and de-highlighting. And next, so we have the raw material, two raw materials that are given as input and the kgs. So we get multiplying 100 into 165, we get 16,500, and 49.43412 into 95, we get the polyester input. So this is the raw material input. Now let us calculate the various waste. We have 4 different type of waste. So cotton waste, polyester waste, mixing soft waste, and mixing hard waste. And we know the revenue through them. I have already highlighted 1288 cotton waste, 1.186 polyester waste, soft waste assumption, and hard waste this much. So the 4 I'm putting it here. So this is our revenue. So we have to subtract this from the cost. So we get the total cost of the clean raw material to be this much. So this is 2196.24 minus 1582.32. We get 19613.92. So this is the total cost of the clean raw material. So the cost per kg of the clean raw material, or we can put clean raw material, total cost of clean raw material. Clean we have to highlight. So this is the cost per kg of clean raw material, or clean raw material cost. This is the RMC, which is the data asked as input in the surveys by Citra. Now this is the main calculation, cost per kg of clean raw material, which is already found. Now let us find the selling price along with this. So for the selling price, we have 2 data that is given, which is the conversion cost to 2.1 in rupees per pound per kg, and next is the profit. So this has to be taken. So conversion cost per kg. So let us take the conversion cost is 2.1. The count is, what is the count? The count that is given here is 80s. We have the count as 80s. So let us take the count as 80. So 2.1 into 80, we get the conversion cost per kg. We have conversion cost per count per kg. Now, so multiplying it by count, we get conversion cost per kg. So we have got the next important data, which is the conversion cost per kg, and already the raw material data we already got. So this is the conversion cost. So the total cost of the material is the total of the conversion cost and the clean material cost. So we have got that value, total cost per kg. Now we know that the profit is 6% of the selling price. So from this we find the selling price without GST. This is the formula used to determine the selling price when the profit is given as percentage on selling price. So selling price is equal to total cost divided by 1 minus profit percentage as a percentage of selling price divided by 100. So we substitute the values for total cost 331.56 divided by 1 minus 6 by 100. We get the selling price with before GST to be 352.73. So from this now we determine the profit. The profit is equal to cost selling price minus cost. So it is 352.73 minus 331.56. So we get this profit. Now what is the GST? Yes, the GST is, yes, we have state and central GST 5%, 2.5, total 5%. So the state and central GST are 8.18. I'm sorry, 8.818, 8.818. So we get the final price in selling price per kg of yarn with GST to be 370.36. Selling price plus GST is your final selling price of the yarn, including GST. So the thing that we approached was, we first did the total cotton line, revenue through waste through the cotton line. Then after that we found the output, revenue through waste through the cotton line, the output of the cotton line to the Drawframe. Then we found the polyester input to the Drawframe. Then through backward calculation, the input to the blowroom line, the revenue generated through the polyester line, and then for the mixing we saw the soft waste and hard waste calculation, and then the output of the ring frame, revenue generated through both the waste in the blended line, and then the total cost calculation, the cotton, polyester that is given as input, and the revenue through waste, subtract that to get the clean raw material cost. Then enter the yarn produced and find the clean raw material cost per kg of yarn, which is the raw material cost taken for the service by Citra. Then find the conversion cost through the data given, multiplying the count into the conversion cost per count per kg, you get the conversion cost. Then the total, you get the addition of raw material cost and conversion cost as total cost. Then finding the selling price and profit, and adding GST, you get the final selling price including GST. Thank you.